Good afternoon, everybody, and welcome to this seminar, both people online and those in the lecture room here in London. So this talk is organized by Young Second and co-badged with IFIT, and is titled Multi-Hazard Coastal Engineering Lessons Learned from Indonesia. Before moving on to the talk, I just want to go through a few things. First of all, let me introduce myself. I'm Marco Beguera. I'm the current chair of the second Young Members Subcommittee, and I'm also the chair of today's meeting. There are also very few housekeeping rules to go over. Please can all online guests keep their videos off and microphones on mute during the seminar. We're going to have a Q&A session after all presentations, but please feel free to type your questions in the chat at any point. And please note that the seminar is being recorded and will be uploaded onto the second YouTube channel. So by dialing into the event, you concerned that any views or opinions you share are being made public. And for those in the lecture theater, if you hear the fire alarm, you need to evacuate through the doors on your left-hand side. So moving on to the talk, I'm very pleased to have with us today four great speakers who will talk about the challenge of improving the resilience of coastal communities in Indonesia that are exposed to multiple natural hazards. Our first speaker is Professor Alison Raby, who is a professor of environmental fluid mechanics at the University of Plymouth, where she leads the Coast Engineering Research Group. Alison is an expert on the interactions of extreme waves with structures, having obtained a doctorate in extreme wave overtopping at the University of Oxford. She has played a key role in a number of collaborative initiatives within IFIT, the UK Earthquake Engineering Field Investigation Team. And today, Alison will provide a short introduction by presenting some preliminary findings from the recent IFIT missions to Indonesia, 18 years after the Indian Ocean tsunami. So without further delay, I will hand over to Alison for her introductory presentation.
Thank you very much, Marco. Thank you. Where do I see the slides on here?
Yeah, so
Thank you. So welcome everybody to this combined IFIT and Young Second talk. And as Marco said, we've got some excellent speakers lined up. And I'm delighted to have the opportunity to introduce to you Dr. Meilianda and Dr. Yunita Idris from the Tsunami and Disaster Mitigation Research Centre, TDMRC, and Dr. Eyitayo Opabola from UCL. Ella and Yunita and I have worked in the field together on 2 occasions now, observing tsunami damage, conducting survivor interviews, enduring long car journeys together, and also enjoying some refreshing coconuts. Tayo and I have just met for the first time, but we've had many Zoom calls as we've been preparing the Indonesian 2022 mission. So it's nice to see Tayo in the flesh today. And we're now all writing the reports together. Well, at least we should be doing that, but we are actually rather busy with our teaching at the moment. Now, the formal association of IFIT and TDMRC goes back to the 2018 mission to the Palu Bay on the Indonesian island of Sulawesi, where there was an earthquake followed by several different tsunamis. And as many of you know, the work of IFIT goes back, well, 40 years now. And here's a list of reports that we've produced over that time. Incidentally, they're available on the iStructE website. But until 2004, they focused almost entirely on earthquakes. And it wasn't until the Boxing Day tsunami of 2004 that we started really looking at tsunamis. And that event changed many things. For example, recognising the need for a tsunami warning system in the Indian Ocean. And it also provided the impetus for laboratory modelling of tsunamis. And that's one of the reasons why Yunita and Ella are here in the UK this week. So EFIT surveyed the damage following the Boxing Day tsunami. And I think you can see Tiziana in that photograph, and that might be Sean Wilkinson next to you. And so they went to Sri Lanka and to Thailand, where major damage had occurred, but they weren't able to go to Banda Aceh at that time, which was the worst affected region, because they weren't able to find local partners to work with on the ground. Now, that would all change. So, following the Boxing Day tsunami, a series of initiatives were brought forth. They were aimed at informing reconstruction, providing information on earthquakes and tsunamis, and considering disaster mitigation in Indonesia. And within 2 years, that had led to the establishment of the current Tsunami and Disaster Mitigation Research Centre. So when the Palu Bay tsunami happened in 2018, TDMRC were the obvious partner for the UK, and EFIT began its very fruitful collaboration, including many projects led by UCL from the UK. In the past few years, EFIT has been looking at earthquakes and tsunamis over a longer period of time, not just a few weeks after an event. So they've done this for Japan and also went back to Nepal in 2022 also. So we saw the opportunity of going back to Palu Bay in 2022. And then we thought, well, actually, we could do a follow-up from the 2004 Boxing Day event also, since we hadn't been able to go to that particular location. However, due to the enormous physical extent of the Indonesian islands, and I've just located there, Sumatra in the west and Sulawesi in the east, we decided probably it needed to be 2 different teams because the travel would be too onerous. And a key aim was to compare the recovery from those 2 events, but bearing in mind the different time that had elapsed and also the different scale. We had a rather ambitious list of objectives, so you won't be able to read them all there. We had good multidisciplinary knowledge in the team and not a little enthusiasm, and armed with those and overcoming some administrative obstacles and the very long journey, which Ella and Yunita have just done in reverse. We met together at TDMRC in October in 2022. And the team comprised myself from the University of Plymouth, and Marco, who's the chair today from Southampton, and then David McGovern, who is based at London South Bank University and is known for his work on tsunami physical modelling at H. Wallingford, and then Keith Adams, who's currently employed by UCL to conduct some of the experiments on the tsunami simulator in Wallingford. And then a team also went to Palu Bay, I think about 2 weeks, maybe 3 weeks later. That was led by Antonios Pomonis, consultant for World Bank based in Athens, and then Eyitayo from UCL, who you'll hear from shortly, and Yuda Adi from McDonald. And then we had overseas partners from Tadalaka University, Dr. Sukiman Nurdin and Dr. Mohammed Marzuki. Now, in putting together the Banda Aceh mission schedule, we were able to link with 2 of the ongoing projects that were based in TDMRC, one of Ella's and one of Yunita's. So this is a photograph of a public engagement meeting that was taking place, and this was considering the hazard due to surface water flooding. And if you look top right, you see a large river, and that circles the post-2004 development there. But actually, the primary hazard there is not from the river, it's not for the fluvial flooding, it's from surface water ponding, because it's a very low-lying area. And where you have vegetation growth in their stilling basin, as you can see bottom right, then that was an issue. So that was an ongoing project. and Ella's husband also was very involved in that. And then we also linked with one of Yunita's projects. And this was a morning that we spent at a primary school where they were hearing about the use of serious games that were used to inform the students, the young people there, about the evacuation routes. And you can see a couple of graphics on the right-hand side. And following that morning, we tried to follow the route ourselves, which was actually quite challenging, even in an air-conditioned car. We did manage to get lost, I think. So during the Banda Aceh mission, TDMRC hosted a focus group discussion, and we had lots of engaged people coming along, community representatives, government officials, NGOs, and it was really helpful to start the mission with the context to understand what they were talking about in terms of their perceptions of reconstruction and disaster preparedness. So that set the tone for the week that we had there. We visited several vertical evacuation structures, and we heard from the director of the TDMRC, Sam Siddiq, about people's reticence about using such structures for evacuating, largely due to cultural reasons. And Yunita has been busy identifying candidate buildings that might be more suitable for evacuation structures. Incidentally, the building on the top right is the previous TDMRC building, which is used as a vertical evacuation structure. We also saw post-2004 developments that had been constructed by overseas donors, NGOs and the like, and we saw some occasions where they had been, should we say, personalised by the residents. So in this location, the ground floor, which was just supposed to be an open stilted structure, had been filled in, and in some places was used as habitable rooms. We saw mangrove plantations, often in the context of aquaculture, not so much in terms of tsunami defence, but I think that Ella might say something about mangroves a little later. Top right was a sad photograph of some mature mangroves on the coastline that were now thought to be dying. And you can see, if I use my cursor here, you can see a soil pipe which goes out from a little cafe, I think it was, and into this lagoon area and has polluted this water and has presumably led to the death of that tree. We also saw port and coastal structures, some of which were already revealing some problems. The Robbleman structure that Keith Adams is standing on there now is subject to overtoppings and scour off the crest. We also went to the international fishing port. I haven't shown any slides for this, but we did have meetings with planners on one of the days, and I think that we were encouraged by some of the understanding for the past decisions and the future strategies, particularly around moving some of the government offices further inland away from the coastline, with a plan to create more of a new town further away from the shore. And then in closing, here is David McGovern, who is also now in the audience. He's reflecting on a video we watched in the Excellent Tsunami Museum in Banda Aceh. And we've still got much reflection to do as we compare the situation in those two locations. Both of them happened a little time before Christmas, so we need to try and distill our findings now. If you're interested to know more, you can look at our blog that's on the foot of this slide. That includes information from the Palu Bay mission also, and Thailand, where we had a mini mission in December 2022. So without further ado, I will hand back to Marco, who will introduce our next speaker.
Thank you, Alison, for your introduction and your presentation on the IFIT missions. And just want to remind all participants that the Q&A session will take place at the end of all presentation, but feel free to post your questions on the chat at any time. Our next presenter is Dr. Ella Meilianda, and Ella is an assistant professor in civil engineering with a strong background in coastal processes and morphology, hydroengineering, and geospatial analysis. Currently, she serves as the secretary of the civil engineering department in the engineering faculty, and she's the coordinator of the disaster risk management research cluster at the Tsunami and Disaster Mitigation Research Center, TDMRC, of Syiah Kuala University in Banda Aceh, Indonesia. She's been involved in several national and international research projects, of which she will be probably talk about in her presentation today. So please, Ella, the floor is yours. And yeah.
Thank you, Marco. Thank you once again, Marco. Hello, everyone. I'm Ella Meilianda, as was introduced just now. Today, it's been a pleasure for me to be in person in UK to present a little bit story about Banda Aceh, how the coastal morphology has been developed after the tsunami 2004. I'm going to talk about the short and long-term effects of tsunami and co-seismic land subsidence on coastal morphology, structure, and vegetation at coastal area near Banda Aceh, Indonesia. So, as everyone must remember, the 2004 tsunami occurred in the Indian Ocean, and one of Aceh, Banda Aceh is the worst affected area by this event. And we are coming from there, and we already established TDMRC, Tsunami and Disaster Risk Management Research Center since 2006. And from there, we developed quite a vast network with local, national, and international. Because our city of Banda Aceh can be considered as the, natural laboratory to learn about the effect of the tsunami to the life of a human being in the modern history. So I would like to just a brief overview about how since the 2004 tsunami, morphology of the coastal area has changed so much in Banda Aceh, as you can see, from 2002, 2005, 2009, and 2014. If you see this very small chunk of, if you see, the bridge of the coastline, where here is the old beach ridge. This is as well. And when tsunami occurred, it bridged this area and make a gap and connecting to the lagoon. But then quickly after that, the sediment brought back in and closed the gap again, and then developed since then as a normal coastline that we have even previously before tsunami. And there's also indication of land subsidence, which it's become it's a little bit difficult to identify, but looking at the remnants of the seawall here, that previously, underneath is the pre-tsunami seawall that is located in the front on the coastline of Banda Aceh. And here on the top is the remnant just a few weeks after the tsunami. And then we also identify some weird situation where tree trunks is actually at the surf zone, which is not really a regular thing. It's supposed to be on the higher ground where it's not exposed to the sea. And this is what we can identify, but very subtle indication of subsidence, but you can see it for yourself. But on the West Coast, we have more evidence on the land subsidence. And you can see these are all coconut tree trunks which is not supposed to be there in the middle of the sea. So this what we can evident along the coastline of the southern west to southern coastline of Aceh. And regarding how to protect the coast after the tsunami, especially the one along the coastline of the west and the south coastline of Aceh. The government started to build this kind of coastal protection, the rubble mount, but because the process of the recovery of the coast, after a while, it requires repairment, because if you see in the 2004 here, you see this is the previous location of this rubble mount installed, and then it has to be shifted seaward in order to protect the area behind. So what I'm trying to say here is that the dynamic between since the tsunami 2004, even after 10 years after, still very dynamic, and it requires further consideration about the dynamic of this sediment that returns to the coastal area if we want to protect the coast. And this is another case where they use the soft measure for the structure, like this is a sandbag that protect the area, because we see these houses during the high tide and the rough wave. The sea wave is coming and flooding the houses, and then the sediment is deposited in the house. So this house is supposed to be really located really quite far away from the coastline previously, but now it's getting really close. And the coastal area here, the coastal road has to be protected, because that's the only access to get along this coastline. But as you can see, after a while, this kind of structures also failed, and they need to have to construct the protection again. So there are a lot of money involved, and it's the solution is really temporary in that sense. So we're talking about the overall situation of the coastal development after the tsunami along the coastline in Aceh. But here I want to show you the area which is really close by to our city, Banda Aceh. And you can see that there are also structures, coastal structures, to protect the inland. This is the rubble mount breakwater, and then this is the refatment. And you can see different places. The morphology responds differently. It's really, I will show you where the location of this. But in general, they want to build this coastal protection in order to protect the new development of the area. Like for here, for example, they built very tall buildings for the housing, and also to protect the compound of the schools behind it. So there are so many proposed for that, but it turns out that there are some measures was not really appropriately designed. So it's overtopped by sand, showing that there are some process still going on towards equilibrium for this area. So, so now we can identify that there are emerging coastal problems that we experience almost 18 years after the tsunami. First one is shoreline retreat, and then sand overtop, coastal flooding, inlet and river mouth closures, because all the sediments brought back into the system, and the lagoon exposure to sea if the barrier island was breached and never closed again, and declining coastal vegetation habitat. So the question in our research is to find out how the coast how far the coast has been recovered, and how the community connects to the coastal vegetation, which in the past they considered it as the coastal protection, but now how with the limited growth of the like mangrove, for example, how they utilize this ecosystem for their life. So what we did is to monitor the shoreline changes in the short term and also in the medium term. So we have collected data from the satellite image and digitized shoreline position between 2004 to 2005 to indicate how far the shoreline has receded due to tsunami, and then how after that in the short term the shoreline position also within the same time frame, 6 months. This is the short term, and then we also collect more data in the longer term from 1989 to 2004. That's 15 years before towards the tsunami, and then 13 years afterwards. So maybe you are familiar with this DSAS, Digital Shoreline Analysis System, developed by USGS. So we use this to be incorporated in the GIS analysis using ArcGIS, and we use the EPR. This is very basic method to measure the changes of the shoreline position. And this is our first attempt to see the changes. On the upper panel, this is the area of Banda Aceh, nearby the ferry port, which is really in the center of the Banda Aceh city. And you can see the changes, quite dramatic. What I want to show you in the graph is that so it experienced quite a considerable amount of shoreline retreat, but because the sediment was in 6 months was not returning quite quickly, so the coastline, the shoreline was still eroding still on the eroding state, reorganize itself actually to smoothen the chaotic shoreline. So this is what happened on the north coast, and then we also see what happened on the west coast, where it is facing the Indian Ocean, and there are a lot of sediments that brought in quickly after the tsunami. So what you see here is that after 6 months, the sediments that was brought offshore by the tsunami returning to the area by 60%. So there's some accretion process going on after 6 months. So there's these two different morphological development in that respect in different area. Okay, so now we extend our research site to this area, which is like on the northeastern of Banda Aceh. So we are interested in seeing the different morphology and how it develops afterwards. So segment A, segment B, and segment C has different characteristic of morphology. So in segment A, it is like a very low-lying lagoonal coast with barrier island and small creeks. And during before the tsunami, it was protected by barrier island And the lagoon system was organized by one inlet only to for the fishermen to get access to the sea. But post-tsunami, the lagoon has now exposed to the sea, most part of it. So after the tsunami, about 65% barrier island has disappeared. And the lagoon, there are quite amount of sedimentation. And the breach of the barrier island has made multiple inlets. But then after a while, after 18 years, the dynamic of the inlet is quite high as well. So it really shows that there are a lot of littoral process going on in that area with quite a sufficient amount of sediments to restore the area. And yeah, so this is the jetties. Because there are a lot of sediments coming in and the littoral transport is quite predominant in this area. So they need to, the fishermen need to protect the inlets in order to get access to the lagoon. And there are some seawalls built at the start of the segment, like this rubble mound here, but it was failed at some point. And here is a little bit overview about how the short-term recovery looks like. The upper panel on the left is showing how the erosion was really high. And then after only 6 months, then the sediment was brought in again. So there's a balance in some transects along the coastline. But in the longer term, we can also see the variation of the balance of the sediment that's brought in, and it makes it looks like that the shoreline becoming more accretional right now. And then in the segment B, this is the area where the morphology is elevated cliff, and then on the top of it, there's this small strip, narrow strip of the beach, and then this is how the situation looks like during eroded by the tsunami. And then in this segment, they have because it is close by to the facilities here. There's a compound of Naval Academy, which is really broad complex. So they need to protect the area. So there are several coastal protection measures that installed to protect this area. And most of them, as we see, buried by sediment, because there are a lot of sediments that brought in. This is how it looks like. It's a little bit, yeah, if you can see on the medium term, the coastal area is actually accreting. And the segment C, it is a slightly elevated lagoon coastline. And before the tsunami, it was mostly erosional, except at transition to higher ground towards the segment B. And then in the post-tsunami, in medium term, the coastline becomes more like accretional. We also want to protect this coastal area because behind it there are the farms and the housing area for the community there that needs to be protected, and this kind of coastal protection was installed. And it looks like that this one is quite stable and it's not overtopped. So it's one of the good example of the coastal protection that fits the purpose of it. And you can see that in the past, before the tsunami, the area was actually erosional area, and then after the tsunami, it becomes more accretional area. So in my conclusion is that the eroded coastal area due to tsunami occurred mostly at young and recent morphology, because like the sand spit that extend from the older barrier islands. So this kind of features that's mostly eroded during the tsunami, and it depends on the how the wave that brought onshore again this sediment and the littoral transport, that in the end it can either close again or just still open. And barrier island breaching by tsunami may cause extensive damage to the lagoonal coastal system, may be recovered if sufficient rate of sediment accumulation is high. In extreme cases, the breaching may not may create new inlets or irreversible loss of barrier islands. Most of the investigated sites affected by the 2004 tsunami are still in the state of recovering towards a new equilibrium, which may be predominantly driven by relatively high rate of accretion, even within more than a decade after the event. So the management in such tectonic tsunami-prone coastal areas should incorporate the post-event changing rates and trend of shoreline development. So based on our understanding about seeing the development of these three different characteristics of a coastline, our future work would be the conceptual modeling of the behavior of the littoral transport and availability of sediments around this area and the morphology response to protection measures. So I don't know, maybe my terms. So I'll just, there are a little bit more about the coastal vegetation. So I just want to show you that there are habitat of mangroves that's really good in place in Langsa, that's the eastern part of Aceh, which is not really slightly protected from the tsunami, although it still has effect on that. But they have the conservation of mangrove in this area because it is located in the Malacca Straits, so it is quite protected. But compared to this area, compared to Banda Aceh, it used to be there used to be quite a dense population of vegetation like mangroves in the past, but after the tsunami, it is difficult to develop to the same amount of area. So we kind of doing a little bit of survey from the survey to the community that live there. So by about 40% of the people who live there currently is those who live as well before the tsunami, but the rest was the newcomers there. So there is a little bit of they don't really understand about how the mangrove ecosystem there, and they're not really attached to the activity, their activities, economic activities is not really attached to this existence of mangrove. So, but and mostly the mangrove ecosystem here is only to protect the area from the wind and high waves. So this is what we have very little observation. So that's it. I will end my presentation with this. Thank you very much.
So many thanks, Ella, for the presentation. And we will now go to to the next speaker, who is Yunita Idris. Yunita is an assistant professor in the Department of Civil Engineering at the University of Kuala in Banda Aceh. She's currently the coordinator of the Disaster Resilient Infrastructures Research Cluster at TDMRC. So now the floor is yours.
Thank you, Marco, for the chance, and it's an honor for me to have this opportunity to address such a distinguished audience about the lesson learned from the recent earthquake in Indonesia. So we've got the opportunity to conduct a kind of the rapid assessment for some schools in Cianjur, West Java, after the earthquake in 2020. So on 21st of November 2022, there's an earthquake about 5.6 magnitude that struck Cianjur, West Java at 1:21 p.m. The earthquake epicenter was estimated part of the north of the Cimandiri fault, and it was then estimated as part the undefined fault. But just recent this morning, we've got the Indonesian has launched their new the seismic hazard map for 2022. So, but this fault not published yet for the updated map. So there is still a discussion about the undefined fault. So Cianjur Regency is a part of the West Java, and it's divided into three parts, which is the north part and center part and south part. So the north part is including some regency like Cianjur, Cilaku, Warung Kondang, Gebrong, and Cibeber, and etc. And this part is what we found is the one that having the more damage construction. I mean, the more damaged area in the most damaged area during the Cianjur earthquakes. So this is based on the surveys of our meteorology and geophysical agency. So this fault is passing through the northern part of the north part of the Cianjur, including like the regency of Cugenang, Cianjur, and Warung Kondang, and etc. Based on this fault, we try to make a rapid analysis of the seismic hazard. So we've got based on the PGA, we separated into like 10 MMI, and we can see that around the fault, the most damaged area, including the area of Cugenang and also Warung Kondang. And you can see the epicenter. It's that estimated by BMKG is the red one, and the blue star is from the USGS estimation location of the epicenter. So, and there are like these are schools that we observe during the rapid assessment survey, including five regency from Cilaku. This is from Cilaku area, and mostly Cugenang area and some of the Gebrong, and also the green one is Warung Kondang area. So we, based on the rapid analysis of the seismic hazard, so the PG, the maximum PG around 0.39 to 0.4. So we use the epicenter, I think it's the epicenter rapid visual survey from that that developed by Professor Tiziana Roseto and team to determine the damage state from 1 to 4 to some school that we selected previously. It's about like 54 schools. Now, what will I provide here? Not building yet, but still schools. So some school can have like a very damaged state building, but at this time I will like provide the most the extreme one. So this is the survey form that we fill for that we use for the observation. And what is the typical or typology of the school buildings in Cianjur or West Java? And I think it's a bit similar to what we have in Banda Aceh as well for the low masonry building. So we firstly thought that it will be that reinforced concrete with the infill masonry, but as you can see, the diameter of the reinforced bar, so we doubt that it could be like classified as the reinforced concrete frame. So probably it's close to the confined masonry or masonry. The diameter of the bar is it's less than like 10 millimeter with a smooth bar, not deformed bar. And typical of the school construction there, using the clay tile for the rooftop, and having the gable and not sufficient enough of confinement for the gable. So it tends to have it tends to fall or damage during the earthquake. So this is the damage state criterion for observation of the schools. So it started from the S0 with a no damage that we can find some school there is with no visual damage at all, and the school already started after 2 weeks. We come there 2 weeks from the event when we come there, and there's also a slight damage with no structural damage, but there's a visual of the hairline crack, and also damage to cladding and windows, doors, and fixtures. And DS2 with no structural component falls, but cracks up to like 3 millimeter can be found in the beam and columns joint, and also on the masonry wall. And when we also have and for this kind of the moderate damage, we can also find the heavy damage to collapse of a non-structural component, such as the roof cover and the gables and also the preparates. So, and this is the figures, the examples of the DS3 that we assume as it is as the DS3 extensive damage, where like the the structural, the roof structure damage, and also the main component of the construction have need to be repaired soon, or it's kind of the excessive damage here. And DS4 that we assume like more than 50% that of the building is like completely collapsed like this. And so based on the PGA group that we used previously for based on the fault, the Cugenang fault, the fault that determined from the distribution of the damaged houses and damaged area. And we digitize and then make estimation of the PGA. So we make a group of the location into the damage state of the observed schools. So this is the group of the PGA or the location, and we've got from Sukalarang and Cilaku. It's can be grouped into the PGA 0.3 to 0.332. So there's no visual like damage state 4 and 3, but they have the damage state 2 building. And mostly no visible damage for schools in this area. But for started for PGA or location that have the PGA 0.34 and 0.36, there's like a gap here, but I think because this is still, rapid analysis, maybe we can come up with a different result as well. If we start to separate into buildings, here still as schools. So we could find like DS4 that completely collapsed, like or more than 50% collapse, and high number of DS3, and started into more DS4 in the Cugenang and Cianjur, where a PGA of that location is 0.36 up to 0.4. So now this is the government, like there's an issue that they will build kind of the new construction, the precast construction called Risha. Risha is the technology that using the panel precast concrete that will having a knockdown to be knocked not knocked. It's a like assembly in the location, but they have the precast one. And this is the example of research school in one of the location in Cianjur. It's I think it's in Cilaku Regency. It's about 0.3 and sorry, it's Cilaku 0.3 to 0.32, where no like damage state 3 happened there. So this school, no visible damage, but having like a non-structural kind of the ceiling, like being interrupted, something like that. And yes, the government plan to build the Rista construction in the high seismic prone zone area. So this is interesting. Interesting issue as well, because we found new, not new. it's a cultural heritage building that built in 1959, having the wooden frame construction with the infill masonry. So this building is no visible like damage, and it's even though the wall is quite, it's a high. I mean, it's a quite high, and we will analyze furthermore for this kind of the structure, probably because the location is not in the very high PGA like we determined first. And so, what lesson learned from this recent earthquake? Yes, we do have several earthquake after, like, Cianjur earthquake, and then we have like a history of big earthquake, strong earthquake, and then damaged earthquake. But I think we still need the preparedness, because every earthquake still have like the victim and also the destruction. And we have we found Vidijaya and Cianjur. It's we found that government mentioned about the undivine fault. So we think that we need kind of the microzonation to see whether there are secondary fault or something like that. And I think each of the archetype buildings need to be like defined as well to see the vulnerability assessment for each location in Indonesia, because Indonesia is very large, big country, and we've got different culture and then different material, and also the knowledge is need to be improved for our local builder for the new technology that need to be applied there. Okay, thank you very much. I think I need to.
Many thanks for your presentation. And the final speaker for today is Dr. Eyitayo Opabola, who is a senior research fellow in resilience and engineering at University College London. His research interests include large-scale laboratory and field testing of concrete structures, post-earthquake repair and retrofit of concrete buildings, multi-hazard vulnerability assessment, and post-disaster resilience and recovery modeling. So it's been involved in a number of post-disaster missions from Africa to Southeast Asia. And please, Tayo, the floor is yours.
Thank you, Marco. Hello, everyone. Thank you for joining this seminar. Today, I'll be talking a bit about some of the things which the EFIT team learned from our mission in Palu, which happened at the end of November, as well as early December. Just to give a bit of a background, my experience in Indonesia hasn't just come from the EFIT mission. I've been involved in another project together with Yunita and Ella, as well as with Tizana and Carmen, which looked more into the resilience of school infrastructure. And the EFIT mission itself was more of a next step to that project. And of course, for the EFIT mission was led by Antonius, who works for World Bank, and we also had contribution from some of our partners in Indonesia. So a bit of what I will present today is related to some of the site visits which we carried out, as well as interviews and focus group discussions which we had with a number of people living in Palu, Sigi, and Dongala. Just for anyone who is interested in having more information about some of the things which I'd like to talk today, you can just take a screen grab of this code and have access to our blog post on this IFIT mission, which covers some of the things which I'll talk about today. And there are also other missions like the missions in Thailand, as well as in Banda Aceh, which was led by Alison. So because this talk focuses more on the recovery aspect of things, I wouldn't talk so much about the damage that happened following the event, but just to give a bit of background on the severity of the event, I would just like to mention that following the 2018 Palu earthquake, over 200,000 people were displaced, and over 4,000 lives were lost. And we had a situation whereby more than 20,000 buildings suffer a wide range of damage from moderate to collapse. So in terms of scale, the amount of losses from this event is quite enormous. So just to put a bit of perspective to the influence of liquefaction in some of the regions in Petobo, Balarua, what you actually see here is the change in the landscape following the 2018 event. On the left, you have the before picture, while on the right you have what it looks like after some days after the event, and you can actually see a large chunk of area which was pretty much submerged by the ground movement, and this obviously was really quite significant and resulted in a significant loss of lives. I'll also just mention a bit about the tsunami. Here is the measured tsunami inundation height, tsunami height rather from the event, and you can actually see a wide range of heights up until 10 meters that were recorded from the event. So also just to show a bit of how severe the event was, here is a video from a drone after the event, and you can see the magnitude of damage that was actually experienced following the tsunami around the Palu Bay area. So moving on, here is a picture which I found, I won't say interesting, but I mean, just to put some thoughts to when we're thinking about tsunami design loads, where you've got this big ship that found its way to this block of residential buildings, and how that has an effect in terms of what we think when we're trying to design buildings. But what did we actually learn from the Indonesian community? One of the things which was really done after the event was the development of a unified disaster-prone zone mapping. And this zone mapping was actually done by overlapping various hazards together. So this map considers ground shaking, liquefaction, tsunami, flood, and ground movements. And the idea of developing this map was for the government to be able to define zones where reconstruction is forbidden, where reconstruction is restricted, and where new developments are actually allowed. So one of the interesting things about this map is you can actually take it to be more or less like a multi-hazard vulnerability map of some sort. But the way it was developed is that the government looked at the damaged states of buildings that were buildings that were damaged by the ground shaking, and based on that, they were able to work out zones to then classify the entire region into like a green zone, a yellow zone, and a red zone for earthquake related hazard. And then they also looked at the field data from the tsunami affected areas, as well as an existing tsunami hazard map to also work out the zonation for the tsunami hazard. The same thing was done for liquefaction, in which they looked at theoretical estimates of the liquefaction potential indices, as well as looking at the liquefaction zones from the 2018 event, overlapped that with the flood and the ground movement cases, and then ended up with this map. So it's a bit of it's a simple approach, but it is quite straightforward in terms of how they were able to define the places where reconstruction was allowed and places where reconstruction is not allowed. I mean, when you think about this, you think, well, all right, it's fine, but this does actually have a very, very big impact, in the sense that when you think about it, for a building that has got a heavy damage and is located in the zone 3 and the zone 4, which is the restricted and the forbidden zone, no form of reconstruction can be allowed if you've suffered heavy damage. On the other hand, if your building were to be located in the zone 1 and the zone 2, where development is allowed, the government would give you some form of money for you to be able to carry out this repair. For buildings that suffered minor and moderate damage in this restricted zone, if anybody wants to carry out the repair, they have to sign an undertaking for this repair to be carried out, and they were given some amount of money to cover up this repair. So in this presentation, I will really focus more on how the reconstruction process worked. And that is because mainly for long-term recovery, which is really one of the metrics for looking at resilience, we really care about the reconstruction process as one of the key drivers for a community. Now, here is a question which has really been around since the Indonesian government came up with the map, and that is because even though it's simple, is it too conservative? In the sense that when you think about the number of people that get displaced as a result of this map, number of people that will have to actually move from their place of business to another zone, do we need to be that strict? And that is really some of the things that the Japanese International Corporation also looked into in terms of describing what they think the map should actually look like. So on the right here is what JICA came up with, and on the left is what the Indonesian government came up with. And you can actually see a difference in that. I can also point out that there are also other studies that have come up with their own variant of what this map should look like. And some of them more deterministic than the others, while some are more probabilistic. But the idea is, given the impact of what this map could have in terms of recovery, how strict should we be when we're developing this type of multi-hazard maps? So like I mentioned, I will focus more on the displaced people because they were really the most affected by this event. So after the 2018 event, some of them had to find themselves in IDP camps for several months. So from IDP camps, after some months, the government made available some temporary housing, which is locally referred to as Huntara, and some of them moved there and spent a couple of months as well. So people were in Huntaras were then moved on to Huntabs, which are the permanent housing a couple of years after the event. And there are still lots of people who are living in the temporary housing until now, because a lot of Huntabs are still under construction. So what were the challenges that happened? On the left, I'm showing a map which detailed some of the recorded IDP camps across the central Sulawesi region. And on the top right, I am showing what some of these camps looked like. You can actually see how close they were together, as well as the type of materials used for them. Ideally, they were meant to be like a makeshift, probably spend like 1-2 weeks or hopefully like a month. But unfortunately, because of how slow the temporary structures were constructed, people spent almost 6 months in here. So talking to people who actually stayed in there, one of the things which they felt were the biggest challenges were the uneven distribution of supplies, as well as the lack of clean water. But amazingly, a lot of people also mentioned the lack of privacy for families. And because, of course, if it's for 1 week or 2 weeks, you might not mind your caring about that. But when you have to spend so much time, it became a concern for people. And that was something that came up in our interviews with people. And of course, we find that to be a bit interesting. So that is really all about the IDP camps. The next thing to then talk about are the temporary housing. There were a couple of temporary housing communities that were built, and we visited a couple of them together with the IFIT team. But here is the distribution of about 60 of these temporary housing communities. In terms of the structure, they are mainly made of light steel frames with gypsum boards serving as the walls. And each unit is expected to pretty much serve 12 households. And in total, I believe the government was planning to initially build about 700 of this, which is covering about 8,000 households. But one of the things that really became quite tricky was that after 4 months, only 30% of them were built, which means 4 months after the event, lots of people were still spending time in IDP camps, which obviously wasn't really ideal because IDP camps are not developed to serve that purpose. But the problem also trickles down from temporary housings to permanent housings, because temporary housings are actually designed to actually have a lifespan of 4 to 5 years. But the issue is when we visited some of these temporary houses and we found people still living there, what we really noticed is because it's been 4 years after the event, we can see the deterioration happening. But some of these people might not actually have permanent housing for another 1 year or so. And it's a challenge because it means within the next 1 year, there could be more deterioration happening and people could find themselves being homeless. And this actually shows you how the community resilience is not really at the ideal level where you would want it to be. So let's talk a bit about the permanent housing units. We visited about 3 of these resettlements, one in Duyu, another one in Tondo, and another one in Pombewe. And this is a drone view of what these settlements look like. So these settlements could either be government-driven, NGO-driven, individual owner-driven, or group-driven. And in terms of the typologies, you have the precast concrete frames, which are locally referred to as the Risha, and then you have the facade, which is made with conwood, which is pretty much a cellulose fiber reinforced cement boards. And these 2 types, we really found them more in government and NGO funded settlements. But for owner-driven settlements, most of them actually used confined masonry buildings, and that is because they were using local builders who are more familiar with this technology. So the last part was really the group-driven resettlement, which is more or less of an initiative which was used to really deal with like clans that want to move together as a unit. And we found one of those groups in Mamboro, whereby the group actually used to live so let me get the, sorry, let me just get a pointer. Yeah, so the group used to live just around here, but the settlement was really affected by the tsunami in 2018. So a new settlement was built for them just about 300 meters away from the coast. And this new settlement, we visited it, and they're actually still houses. And the idea is the government, according to what we were told, the government spent some time testing out the structures to ensure that they are tsunami resistant. So you have the Risha panels being at the base, at the ground floor, and then they have a roof, a timber frame, as well as timber flooring being at the top of this Risha frame. And obviously, like we all know, keeping the ground floor open is good to allow the tsunami waves to pass through. We are carrying out detailed analysis as well to really see how this can be designed using hand calculations and all. But according to what we've been told, structural testing was carried out. But going through Palu, there was a bit of an interest in really seeing the country's richness, history towards steel housing, because I found a multitude of those type of buildings spread across the region, and there has always been a culture of steel housing in Indonesian vernacular architecture. And here is a picture depicting a painting of a building on that island from the 1800s. And you can actually see that it's got that that appearance of what we would typically refer to as a tsunami-resistant building nowadays. I mean, you could actually find pictures of even buildings with bigger columns at the ground floor, which tend to show that these people had this local knowledge of how to build to avoid the impact of tsunami. But digging deeper, something which I found was most times the locals never related it to more of a structural need. It was more or less thinking about it in terms of cosmology. So they pretty much saw, so in cosmology, they thought of three types of worlds: the underworld, the middle world, and the upper world. And that actually had an influence in their form of architecture. But in terms of how it works, you actually see it serves a lot of advantage, because some people also know that, well, we raise our floors to allow water flow underneath it and keep the floors dry, which is pretty much something that is interesting to know that has been there for a very long time. Another thing of interest is actually the high opening ratio for these houses. And I can't but think, did they have an understanding of what breakaway walls could mean? And maybe they've always thought about that as well. Who knows? But it just shows us that people have always had ideas about how to design some of these buildings. And of course, around the 1800s, before then was the influx of the Dutch, which changed the architecture of these people. But regardless, we know that knowledge has been there. So while we know this, it's also important to understand people's culture and how they perceive risk. Here is how the former picture which I showed on how the buildings were designed and given to this community. But on the right is actually what we saw when we went to visit. So people pretty much closed down the ground floor and turned it into another living space. And and this is really quite a big issue, because when you talk to them, they were not really thinking so much into whether they shouldn't have done that or not. And that is something that is a bit of a challenge, because whenever NGOs have interventions like this in community, it's important for them to probably go back there after some time to really ensure that these are not the type of cases of modifications that could have impact on the building, on the vulnerability of the structures. So that there goes information about residential buildings. Now we're going to talk a bit more about engineered buildings like hospitals as well as large schools. So the Islamic State Institute was severely impacted by the tsunami in 2018. And as part of the rebuild process, the 4 new structures were being planned. And like I mentioned, you have the zone 3, which it's a bit of a restricted zone. And this new campus is actually at the boundary between zone 4 and zone 3. And they wanted to build there. But something else which is quite also interesting as well is that this area has got a high liquefaction potential as well. So you have a situation whereby you are designing a building against earthquake, tsunami, and liquefaction. So we visited some of the buildings, and this is really what it looks like. Apart from the fact that they are designed to resist these multi-hazard, the buildings have also been designed to serve as vertical evacuation centers. And you can see how large some of these columns are. So I think on the average, the columns in the building are like 800 millimeters, and the spacing is like 4 meters, showing how their intention of actually making these buildings as stiff as possible. Also, the vertical evacuation facility can accommodate about 800 people, and there are 25 toilets provided, and it can also resist, it can protect against tsunami up to the height of about 11 meters. So for these buildings, each of the building has got a board pile of about 30 meters, I think. And in terms of the consideration, they actually believe the building can protect them against tsunami, liquefaction, and earthquake. Something else that was also interesting was another hospital that is located in an area prone to ground shaking and liquefaction. So the previous hospital had been damaged by the earthquake, and for them to actually build there, because it's zone 3, there had to be special consideration as well. So the new building is a 5-story building, and another design driver for them was actually post-disaster functionality, because it's a hospital. So for them, what they considered important was having 40 meters broad piles, and then have the building to be base isolated, while also ensuring that the beams and columns are well detailed. So this is an example of some of the installed LRBs. And then obviously we did some survey around the sites, and we could see some of the code conforming structural components, as well as see the quality control on the site. And something that has really been coming up as well in terms of post-disaster recovery has been the interdependence of infrastructure. So following the events, obviously, anybody who is familiar with Palu knew that the Yellow Bridge collapsed. And because of that, there were also damages on the road leading to the bridge. So there are discussions about, where to have the new road pass through. So this is actually called the Palu Coastal Rehabilitation Program, which will involve reconstructing this bridge, and then around here have some an elevated road, which would also safeguard the community, and then have some mangroves as well just before the road. But the problem is it's taking so long for this to actually start, to the point of even getting it completed. So what happens is there are lots of businesses here who are actually waiting for this road construction to start or to even finish before they can repair their own buildings, because nobody really knows how long it's going to take, and how they should actually plan their own business. So here is an example of the impact of infrastructure dependencies on business continuity. So just to round up, we spoke with about 100 people during our time in Palu, and we're able to gather data on some of the socioeconomic aspects of recovery and what they think was important to them. And one of the highlights is, while we think shelter is quite important, some people felt they cared more about business continuity rather than the place of shelter, because it's easier for them to get shelter themselves, but they were knocked out of business. Another thing which we tend to forget is really the non-physical domain of recovery, which is really the psychosocial part of it. And a lot of people were traumatized by this 2018 event, and we pretty much heard a lot of stories from people who were traumatized. So finally, what do we think is the next step? What do we think we're going to do with the lessons that we've learned? It's really how we think we can contribute to disaster resilience using some of these things. So our thought is, how can we go from less resilient communities, which actually take a very long time to recover with a high level of functionality loss, to communities that have a lower level of functionality loss, as well as a high rapidity in terms of recovery. And these are some of the research work that are ongoing here right now. And hopefully in the next coming months, we'll be able to share more details about some of our research work in terms of post-disaster recovery modeling, as well as recovery enhancement frameworks. Yeah, thank you.
Thank you very much, Ayo. And before moving to the Q&A. I would like to thank all the speakers for their great presentations today. For the Q&A session, I'm going to look at the questions online first. And I believe there are a couple of questions for our speakers. So we can spend the final minutes of this presentation today answering this question. There is a question from Costas with reference to the first presentation. So imagine the one given by Alison. So maybe if you want to come here, Alison, to the podium just to make sure that you can be heard. So Costa says that he noticed that the joints of a reinforced concrete building were damaged by the earthquake as they were poorly reinforced. Also, the evacuation structures appear not to be adequately braced for seismic force, and some buildings had open ground floors with an increased risk of developing a soft story mechanism. This proved one of the most common reasons for structural collapse around the world. Is there any work being carried out to strengthen buildings in anticipation of the next earthquake? So maybe it's about how Banda Aceh is currently. Yeah, it's more for me actually in terms of let's say it's actually actually it's also it's a question about Tayo.
Story.
Yeah, I think what I believe there is a question about Banda Aceh. The reconstruction took place some time ago. And for the new buildings, there's definitely more attention about how to, build, avoiding soft story mechanism. But there is a clear, when we were there in terms of the mission in Banda, there was a clear problem with the existing building stock that was not that new had survived the earthquake. There are many critical interventions that should be made, and possibly will be done in the future. But it's more likely that for the new buildings, this will be prevented more. It's more likely than for the existing building. Yeah. And maybe Tayo can add also what
I think soft story mechanism, I mean, obviously, like we know, is related to the story with the weakest story share capacity. And in the case of when you actually have this ground floor mechanism, this opening in the ground floor, there's a way in which you can design the buildings already to ensure that you actually don't have your weakest story share being at that ground floor. And when you think about the fact that already capacity design, we already predetermine our mechanism and we design for it. In the case of the buildings in the Islamic State School, they are effectively able to design these buildings to ensure beam hinging mechanisms just by using the principles of capacity design. So by capacity designing our buildings, we are already ensuring that we don't have our columns hinging and rather forcing the mechanisms into the beams. And that is actually a way to avoid the soft story mechanism.
Yeah, I believe also building on this sort of topic. Costas has a question for you, Tayo, about the statement of responsibility. So he's asking whether minor and medium damages are being repaired and possibly strengthened by the owners who must meet a statement of responsibility. That's the question. Does this mean that the state is not going to support any damages in the future?
I can't actually provide a 100% correct answer, but I think yes. That is it. Like you're taking responsibility for trying to build in a place whereby you already know it's a high disaster prone zone, and you take responsibility for whatever happens to you. Yeah.
I believe like the final question by Costas has been already addressed by talking about soft story. One thing that we observe in Banda Aceh, for instance, is also we're dealing with usually relatively low-rise structures, so it might be there are many high-rise structures where the soft story mechanism is usually more catastrophic in terms of impact. Yeah, I can see there is one participant typing the question. Tufan, if you want to also just open your mic and ask a question, then it's an easier way to go, and then we can close the talk of today. Yes. Okay, for Ella, so maybe if you can come here, Ella. There's a final question by Tufan, who is a researcher at the University of Southampton, so it's a colleague of mine actually, and he's from Indonesia. So is asking what is the main reason for the coastline has moved forward after the tsunami? Don't you think it should be the same as before? But the excess water may be there and could be drained. Or there could be some drainage. Is that clear or want to?
I think I got the first question. I'll try to answer that. Thank you very much for the question, Pak Taufan Abadi. About why the coastline moved forward after the tsunami, it really depends on the how much sediments still around and can be brought in back to the coastal system by the regular waves that induce the currents, and then it creates a littoral transport. That is really a normal process to make the coastal area keeping the shoreline as in its position. But since the loss of sediment is quite a lot due to tsunami, and it takes a while until and some of them even brought really offshore, and in which the normal regular mechanism of waves cannot really transport back those sediments. So there are cases where when the sediment is still around, it can be brought in and then make the shoreline move seaward. But there are some other cases where you don't have enough sediment in your system to be brought in, so it will be eroding. The shoreline will be eroding. I think that's the answer.
Okay. Thank you, Ella, and thank you everyone for joining this lunchtime talk. If you have specific questions, of course, you can also find details of all the speakers easily online, and if not, just send an email to the SECET, to me and to SECET in order to get more information. But this talk will be also uploaded online shortly on YouTube. So thank you very much, and see you next time.